Hello all, my name is Amol Paliwal and in this video we are going to see question number 1679 on lead code, which is max number of k-sum pairs. You will find this question familiar to the two-sum problem. So now let's discuss this question. So the question statement says that you are given an integer array nums and an integer k. In one operation you can pick two numbers from the array whose sum equals to k and remove them from the array. Return the maximum number of operations you can perform on the array. So what's the question statement is saying that we have an array of numbers, so we have to find two such elements. Let's explain with the help of whiteboard. So we have to find two such elements that sum of those elements would be equal to the given value, which is k. So in this question we have 1 and 4, which sums up to value of k, which is 5. So now let's discuss the brute force approach of this question. So in the brute force, let us first consider an array of numbers. So we are considering elements 1, 2, 3, 4, and 4. Now the brute force approach says that we have to traverse whole array two times. It uses two pointer approach. So what we shall do is that we should traverse the whole array for every element and find if the sum of this first element and the another element equals to k or not. But in this we would face another problem, like consider a situation where we have selected the elements 1 and 4 and k equals to 5. So these elements would give the sum 5. But when the pointer reaches to another 4, the sum of elements would be also 5. So the count value would be probably 2. But this is a like loophole, because we have selected two elements and we have to remove that two elements from that array, and we have to not consider them for the next step, as the question states clearly. So what we shall do, so we will now update the elements which participated in making the sum equal to k to the value of -1. In this way we will make sure that we will not revisit the same element again and again and form its pair in the answer. So let's see the brute force approach first. So here is the code for the brute force approach. At the initial stage, we shall declare a count variable which should store the final answer of how many pairs which give the sum equals to k. Now we would traverse the array with a loop. Now we shall see if the number equal to -1. It states that we have already considered that number. Now we have another loop for the second pointer, which is the j loop, and which starts from the index I plus 1. Now we shall also check the same condition, that if elements is considered before or not. If not considered, we will check if the sum of two elements are equal to k or not. If the sum is equal to k, we will just update our count variable and also update the numbers to -1, because we have already taken that number into consideration. Once we have taken the numbers, we will break out of the loop, and at the final stage we would return the count state. But this approach so let's discuss the time complexity of this approach. So as you can see in the code here, that the outer loop runs from 0 to nums dot size, which is, let's consider nums dot size as n, and the inner loop runs from the index I plus 1 to nums dot size, means the outer index run from 0 to n and the inner index runs from 1 to n. So probably the time complexity would be n into n minus 1, which is equal to big O of n square. So in this case, the program will give a time limit exceeded, because the time complexity of this solution is big O of n square. As you can see here, that the question gives the error of time limit exceeded. Now we shall discuss another more efficient approach for this problem, This is also a two-pointer approach, but in this approach, we shall sort the given array first in ascending order. Now let's see the array 1, 2, 3, 4, and 4. Now in this, we shall sort the array in ascending order. As you can see that array is already sorted in ascending order, so we have take it direct into consideration. Now the approach says that we have to take the first pointer from the first index and the last pointer from the last index. So if the sum of first and last is equal to k, so we should increase the value of count. But if the sum is less than k, we should just increase the lower pointer, which is the first pointer. Now the loop runs from 1 to till our two pointer meet at a position. This would be a condition like first is greater than last. Now let's see the code for this approach. So the code says it's all. Now in this code we have sorted the array in ascending order using HTL sort function. Now we have taken a count variable for storing the final answer of the number of pairs which give the sum equal to k. Now we use a loop from 0 to numbers dot size minus 1. Sorry. Now we use a loop which contains two pointers. First one is I, which starts from 0. The second one is j, which starts from the last index. And we shall learn this loop until our first is less than the last. So we compare the element like sum of them is equal to k or not. So if the sum is equal to k, then we shall increase the variable of value of our count variable, and we shall increase the value of I and decrease the value of j. But if it's not the condition, we get the sum less than k, then we shall increase the value of I, and if we got the sum greater than k, then we shall decrease the value of j, and at last we will return the variable count. So let's analyze the time complexity for this approach. So the time complexity for this approach would be n log n for sorting. Also, we are traversing the array again, which takes the complexity of big of n for traversing. So the overall complexity of this approach would be n log n. But again, this is not the very optimal solution. We can reduce this time complexity to big of n. Now we shall discuss how we can do it. So in the third approach, we will use hash map to store the values. The approach is quite simple and we will directly jump to code for its explanation. So in this approach, we are using HTL map function to draw a map. Also, we are using the count variable which would return the count of number of pairs. Now we would traverse the array from 0 to the end. Now we shall see if the number already exists in map or not. If the number exists in the map, now we shall see the another number which is the difference of k and nums exist in map or not. If the number exists in map, we shall increase the value of count variable. Also, we shall decrease the value of uh, the k minus nums I in the map. Or else, if we do not find that if the value exists, we shall update the map with the new value of the error, and at last at the end of loop we would get the count value and we shall return it. So this approach uses big of n time complexity and big of n space complexity because we are using an hash map. So that's all from my side. Thank you.